Hello everyone, welcome to Maths IAC. Here's another proof question, and this question is related to quadratic sequences. Please pause the video and try this question. The nth term of a quadratic sequence can be written in the form Tn equals an squared plus bn at c. Prove that for any quadratic sequence, the following three equations can be used to find the values of a, b, and c. The first term is a at b at c. The second term, take away the first term, is 3a at b. The second difference is 2a. Now, for the first term, n is equal to 1. The second term, n is equal to 2. Third term, n is equal to 3. Now, an squared plus bn plus c. So for the first term, n is 1. So it's a times 1 squared plus bn, b times 1 plus c. 1 squared is 1. So that's a at b at c. So I've already done the first part because the question is to show the first term is a at b at c, and I just got that here. Second term. Now n is 2. An squared. So a times 2 squared plus bn, b times 2 plus c. 2 squared is 4a plus 2b plus c. So this is the second term. So let's do the third term. N is 3. A times 3 squared plus bn, n is 3. So b times 3 at c. 3 squared is 9. So 9a at 3b at c. That's the third term. Now, second term, take away the first term. So let's do that. Second term is 4a at 2b at c. Take away the first term. First term is a at b at c. So let's do the takeaway. A at b at c. 4a at 2b at c. Now, there's negative sign outside, so they all become negative. Now let's simplify this. So we have 4a here. Take away a. 4a take away a is 3a. Now we have plus c and minus c, they get cancelled out. 2b take away b is just b. So I get 3a at b is the second term, take away the first term. Second difference is 2a. Now let's do the first difference first. So we already figured this out by second term take away first term is 3a at b. Now let's do the same thing here. So I need to take away the second term from the third term. So let's do that. 9a take away 4a is 5a. 3b take away this 2b is b. C take away c is nothing. Now I need to get the second difference. 5a at b, I have to take away 3a at b. So let's do that to get the second difference. So I can multiply this out. So I get 5a at b, take away 3i, take away b. Now again I can clearly see the b's get cancelled out. 5a take away 3a gives you 2i. That's exactly what the next part is asking.